We're going to get some more C basics going here today. We've got recursion, header files, bit shifting, maybe a couple other items in there. We can discuss what the difference between heap and stack allocation is. Reading and writing files from disk, the disk IO, probably using some standard libraries like stdio. Can be doing some of those things here. And bitwise, bit shifting, and the difference between bit shifting and bitwise operators. Looks like we got a couple things on there. We previously, what did we cover so far? All right, let's look at what we covered so far. We covered function pointers, strings, right? Basics, C basics, by reference, passing variables by reference, so you can mutate the variable. We did structs, we did unions, and we did typedefs, which is a nice way to sort of define, I don't know, I guess your own, I mean, it's fine. It allows you to type less code. If you define a struct or a union and then use a typedef along with it, then you don't always have to use the keyword struct and union when defining that struct or union. Nice little benefit. Malloc, you need to say how much memory you want to allocate. And calloc will do the same thing, except for it will zero out all of the memory. So it allocates and it writes into the memory, so that way it sort of clears out the buffer. Usually I don't, because it's more expensive, so you're writing. I usually don't do that. I usually don't. I use some questions, though we'll try very few times to copy and paste. We want to type everything by hand so we keep our skills fresh. We don't want to atrophy. We do not want to atrophy. Okay, so that's the plan. That is the plan. Leo Croak, thank you for pasting that link over there in Discord. Thank you, thank you. All right, let's close this window here. Boop. Okay. So where do we want to go? Redo. Yep. Okay. Let's close that. OS. All right. Get status by main. Okay. We want to. Let's do a little bit of Git workflow first. Then we just disabled Copilot, so we got that going. Although that's not quite on the list of C basics, is it? At least we got that done. Let's mark that. We got it done. Let's say, hey, we got it done. I'm happy about that. All right, let's do the Git workflow. All right. Excellent. All right. So, first step, let's create a Git repository. Say git init, right? We'll do git init. Let's do this. Let's go cd/desktop mkdir project cd project git init. That's saved one, right? So you just created a new Git repository. All it does is it creates a file right here, or directory, called .git. You can open that directory. There you go, open that directory. You get a whole bunch of things. Config, descriptions, heads, a whole bunch of things that are just metadata about your current project. Git status is another one. So we've covered let's do this, git.text. All right, so git init, right? This will initializes init, create repo, create tracking of source code. Okay. Next, you want to do git status. Always run git status. Basically, just run git status even though you don't think you need it. Run before any other commands, after init, and before any other. Okay. Then you do git add file name, add to the working tree, git commit -m, commit current working tree, and then git push origin main, right? These are the commands. If you just do these commands right here, you're good to go. If you do just those commands right there, you're good to go. So we can save this file here, right? Let me say git add, git.text, git status. Always run git status, right? Git commit -m, added git text file. There you go. There you go. Git log. I should have added git log. You don't usually need to use git log. It's just nice. So let's see here. That was it. So we did our git here. Oh, wait. There we go. So we did this, and then we should also add git log. Then we can do things like git branch, and then git checkout -b, branch name. Right? You could do things like this. These are other things for cross-team stuff. This is cross team Git stuff. And there's things like merge, which you don't need to do if you're using GitHub. If you're using GitHub, you don't need to use git merge, but you could if you want to. Okay, git status, git commit, git add main, git commit, updated the main. All right, let's actually put spaces in there. Updated the main list for C basics today. That's the plan. Push that to main. All right, so let us do a malloc. We'll do a malloc. So I will say vi malloc.c. And then we'll open up the, what was it? The calloc over here. Okay. Actually, what we'll do is we'll put it at the bottom of the screen. I think it's a little bit better. We'll put it at the bottom of the screen. Make it a little bit easier to see. Okay, there we go. Deepak on LinkedIn. All right. Sounds good, Deepak. We'll get you there. We'll get you there. I'll see if I can go back and grab you in a bit. All right, so we want to do int main. So you got to get your basics open here. Return 0. And then we can say, we'll say void pointer make memory. I'll say memory. And then we can say how much. Int how much. We'll do underscore. I like that. I like that idea. I think that's a good one. And then we'll return something. We'll return something there. Okay. So we do need to do a malloc. So we'll say, we'll just do make memory. We'll do a char stir. We'll go like that, char stir. And then we need to assign it to an address, malloc. And then we say how much. Or how big, right? How big. And then you could do it by a data type. Although, since this is in bytes, right? Malloc does bytes. It's a stir, which is a char. We don't need to have a much. How much? How many characters? Many chars. All right, there we go. Then we return str. Or, but if str equals null, you want to have some checks in here. I guess you could just say return null. Although this doesn't really do anything. Return null. Because you're going to return null anyways. Return null. I mean, kind of. You probably should do this. You probably should do this. So I like this pattern. That builds. Let's see if that builds. Okay. Wait 1 second. Close. Split. Clang. What do we call this? We call this malloc. Malloc.c-o malloc. There we go. So include stdlib.h. There we go. Now that should work because we're using malloc, and we're doing C basics today. So you can see here, these are the things that we went through previously: function pointer, strings, malloc, calloc, passing references, variables by reference, structs, typedefs, unions, enumeration, static variables, macros, and now we're on to malloc, calloc. We're going back to that really quick. We're going back to it. Also, you got to make sure to free your memory. You can't forget to free it. You can't forget. Well, you can, and it will be fine sometimes, but sometimes it's not. So as you can see, it built perfectly fine, and it runs perfectly fine without freeing and everything, right? So you got to remember to free. You got to remember to free here. Right here, you guys got to remember to free. So let's stick to low-level languages. We'll stick for now. We'll stick for now. We'll probably go some higher level, though. I like my higher level. Technically, C is C++. You got it, Aiden. You know it. It's so true. You wrote a term paper on it for one of your courses last semester. That sounds like you're on the right path. Definitely physical. If you're building applications, you're compiling them as a binary, you want to import them into a very lightweight container called from scratch, so it keeps it really tiny and small. When you put it into a microservices orchestration system like Kubernetes, and it will be faster than anything. This is the build phase. Build, and this will be the runtime container. Let's get that. Runtime container. This is the build container. Right? Build container. Container. Gotta spell it properly. Gotta spell properly. Container. Container. All right, good. GCC. Yep, right. We're using GCC now, you guys. If you're using libs, that's similar. Your thing to compiling is not an issue. Zig CC makes it super easy as well. Nice. Good old Alpine, right? What's Musel? That is... let's find out. musl-dev Alpine. All right. It is, here you go. Here's the information. All right. Refers to the development files for Musel, a lightweight C standard library that Alpine uses instead of more common glib. Make Alpine images small and efficient, provides headers and libraries needed to compile software that links against Musel, often installed in Alpine package. We're getting our C code compiled and built into a container. And specifically, I want it to run in the Scratch container. Have you heard about this? Have you heard about the Scratch container? If you haven't, it is the most lightest, simplest, cleanest, smallest container that you can have. It is the bare minimum. It's the bare minimum. So I want to, all right, so we have to do copy from builder, the build / Malloc. We put it here. There we go. So that should do the trick. Container getting going here. See if we can make it happen. So we should be able to build this now. Let's see. So Docker, let's see. Docker build. Okay. All right. What is this here? As builder from scratch from equals from equals. All right, missed that. Equals. All right, let's try that. All right, better. Hey, look at that. Look at that. It's working. Oh, wait, just kidding. Just kidding. Wait, what am I doing this wrong? As builder from equals builder. What is missing? All right, you guys, do you see what the problem is? Do you see what the problem is? From as casting, as and from keywords casting do not match. Either way. Hello, R3 Vi Gosling. Good to see you. Wait, so the problem was case sensitivity of the Docker syntax? It was, right? Isn't that ridiculous? So ridiculous, you guys. Absolutely ridiculous. It's some silly stuff. We did it. All right, I'm feeling pretty good now. I'm feeling pretty good. All right, so there you go. That's how you do. All right, so we did it. We revisited Malloc, right? We revisited Malloc. We typed it twice from scratch because we had to, because we accidentally deleted the file, and then we got it working in Docker. Doing C basics today. We're doing C basics. Here's all the things that we covered today. We revisited Malloc. We did Docker file. We did Git workflow, and we updated Recursion. Hey, you got it, right? Abigail, Recursion, Abigail. You got it, Recursion. Think MLX. Silicon architecture is pretty interesting. It's so fast, no need for NVIDIA, right? I'm not using NVIDIA. I'm using a Mac. So I'm just using the built-in accelerator, and it works really good. It works really good. We can implement Pascal triangle algo. That sounds like that would be a thing. I don't know if we're going to do that or not. All right, let's see here. Include stdlib.c. Include stdio.c. Int main. There we go. We say return 0 to get the basics going. All right, and then we're going to define a function that recurses int fib, and then we'll have a comma b. Will be ints. To show you guys what that looks like. This is why you don't do recursion. I'm just showing you what recursion is. I'm going to show you why you don't want to do recursion. Would you make projects for Rust beginners to help us practice? Yeah, we should do that too. So we'll do Rust. We'll do Rust basics. We'll do Python basics. We've done some assembly basics. The recursion stack, yeah, larger so you won't overflow. Technically arbitrarily large. Really? So it might be a trick, right? A plus B. Is this it? Return A plus B. I have written some recursion in C for graph stuff on compilers I made. Okay, Neva, that is actually a good use case. So if you're doing a walk, right? If you're going to walk something, like walk a tree, recursion's okay. I think recursion is a pretty good okay in that situation. Fib, oh, thank you. Savon, thank you. Fib equals fn. Okay, so fn, so fn minus 1 plus fn minus 2. All right, so we need 2 fibs. Okay, let's try this again. So let's do int. We'll call this s savon underscore fib, which is the actual fib. It's going to be 1 int the data. We'll say number, and then you say return savon fib number You said -1, -1, and you say plus Sivan fib number -2. And then it will return. Okay, so we need to have an exit point, right? If it's below 0, if number less than 0, return 0 or something maybe, right? There we go. Is that it? Let's try Sivan fib next. Let's close that out. Okay. So end W Sivan fib. And then we do, we'll say 100. Okay. And then we'll just comment this out because we're not using this right now. There we go. There we go. Fib function takes only one parameter because it's decrementing. Yep. Thank you, Priyank. Thank you, Priyank. Thank you. You're absolutely right. We got Docker file updates, Docker file, recursion, and a party popper. There we go. Push main. Done. Boom. Easy to go. Everyone, well, we might continue on some of the, because we didn't finish with the C basics. So we might finish. So there's a few other things in here that we might want to do. We might want to do header files, some bit shifting, and we also could talk about the difference between heap and stack allocation. We can do some reading and writing of files. We can do those sorts of things. And then we're good to go. Although we do have to be careful with reading and writing files because it is, there's a cost from, there's a cost. Jeff